Hello everyone, welcome back to 1033 MAT Intermediate Algebra. So in this lecture, in this video, I will be talking about rational expression and how to simplify rational expression. I will be discussing how to add and subtract, multiply and dividing a rational expression. What is rational expression? In the previous class, I talked about a trinomial, right? And we learned how to factor trinomial. Trinomial is an expression, it's a mathematical expression. Now think about it. If I have a trinomial and I have a binomial, a trinomial, it means a mathematical expression that contains three terms. Binomial is a mathematical expression that contains two terms. So if I set it up, one over the other, I can create a fractional expression. That fractional expression is called rational expression. Or rational, it's called rational expression. Or the difference between rational expression and fractional expression is that for rational expression, it must be a polynomial, a trinomial of first degree. Okay, or the second degree or the n degree. Okay, there's no radical. Okay, now let's jump to the definition, and we're gonna go through some example. Then we will be learning how to simplify those rational expression. Okay, so let's get started. I think I'm gonna go with the yellow color. So today I'm gonna write the topic first. Rational expression. And simplification. Alright. Okay, let's jump to the first part of our video. Rational expression. What is rational expression? Okay, what is rational expression? Last time we already talked about trinomial. So if I have a trinomial, and trinomial is in the form ax squared plus bx plus c, right? And this is trinomial. Okay. And what if I have expression that contains only two terms? For example, ax plus d. This is binomial. All of this, the trinomial and binomial is they are considered a typical example of polynomial. Okay, so all of this is polynomial. Okay, so this is polynomial. So what is polynomial? So you never learn what polynomial is, but we just learn trinomial. So trinomial is the typical example of polynomial. Polynomial that contain n term with n degree. Okay, so the standard form of polynomial will be anx to the n plus an minus 1 x to the n minus 1 plus an minus 2 x to the n minus 2, okay, plus plus c0. This is polynomial. Okay, and think about it. This is the second degree. This is n degree. So this is n degree. This, the highest degree over here is second degree. The highest degree over here is the first degree. Okay, so that's why we call the second degree here. Sometimes we call the trinomial, we call the second degree polynomial. Sometimes we call binomial first degree polynomial. Okay, we probably have something like this. For example, have a 4x to the third minus 2x squared plus 4x minus 1. This is the third degree polynomial. Okay, this is third degree polynomial. Now, if I go ahead set one polynomial over the other polynomial, then we can create something called rational expression. We can create something called rational expression. So rational expression, it must be in the form. Okay, this rational expression, it must be in the form of P1, okay, over P2. P1 is the polynomial, and P2 is also polynomial. It could be any degree, okay? It could be any degree. It could contain two variables if they want it, okay? For example, I have a rational expression like this. What if I have 1 over x? Okay, 1 over x is a typical example of rational expression. Or I can have 1 over x squared. 1 is a 0 degree polynomial. X is the first degree polynomial. X squared is the second degree polynomial. Or what if I have something like this? 4x to the third minus 1 over x plus 2. This is also a rational expression. So as long as you have the variable x in the denominator, it is rational expression. Now I'm going to give you something else. Now you tell me this is rational expression or not, okay? Example 1, this is example 2. I'm going to give you something like that. What if I give you square root x squared plus 5 over x to the third plus 2x minus 1. Do you think this is a rational expression? The answer is no, because we have radical. We're not allowed to have radical nor absolute. Okay, if we go ahead and throw away the radical symbol, yes, this is rational, but because it's radical, so this is not rational expression. Okay, this is called fractional expression, but it's not rational expression. Okay, it's not rational expression. Now let me give you another example, and you tell me this one is rational expression or not. Okay, what if I have 4x to the third minus 2x squared plus 5 over 2. It is a rational expression? You think so? On the top we have third degree polynomial. It looks like it's satisfied, right? It looks like it's satisfied this form. So this is polynomial. This is also polynomial. But the thing that right over here is a number. It is about the number is a 0 degree polynomial. But the thing is that if we go ahead and split them up, so it becomes a polynomial, one polynomial only. There's no two polynomials. Okay, so this one here is not rational expression because there's no x under, because no x variable in denominator. Okay, there's no x variable here. If this one is 2x, then it is rational expression. Okay, so this is not rational. Okay, this is not rational expression. Okay. Now let me give you another one. So far we have done 3 examples, 4 examples, right? And all of them is in terms of x. There's only one variable. What if I'm going to give you something with 2 variables? Okay, what if I give you something with 2 variables? What if I have Over here I have 4a squared plus b over a minus b. It is rational expression? It is. Because we have variable on the top a and b, and we also have variable at the bottom a and b. Even though we have two of them, that's fine. But it's still considered a rational expression. Okay? Alright? Okay? Or I can have something really complicated, something like this. I have 2xy squared minus 4x to the third z plus 5 over xyz minus 1. This is rational expression? Yes, it is. It is. It's still considered rational expression even though we have three different types of variable. But the most important thing is that we have variable in the denominator. So it's still considered rational expression. Okay? Okay. Let me see. Alright. So after you know what rational expression already, on the second part of our lecture, we'll be learning how to add and subtract. We're gonna learn how to add and subtract a rational expression. Adding and subtracting rational expression. Okay. And rational expression is like fraction, as I say. Not all fractional expression is rational expression, but rational expression is a fraction. And because it's a fraction, so we have to follow the rule of adding and subtracting fraction. Remember, when you add and subtract fraction, if you have the same denominator, you're gonna keep the denominator and you add the top. If you have different denominator, then you have to find LCD. You have to find LCD. So on the first example, okay, I'm gonna give you something with the same denominator. Okay, let me see what I'm gonna give you. Okay, so this is what I have. I have 11x plus 28 over x plus 4. Okay, 11x plus 28 over x plus 4. Okay, and I want to add it to x squared over x plus 4 plus x squared over x plus 4. Alright, so what do you see over here? So you see that we have two fractions, right? Two fractions, and the denominator is x plus 4, and over here also x plus 4. Okay, so this is the same denominator. This is the same denominator. So all you have to do, we just go ahead and keep the denominator, okay, which is x plus 4, and we combine this together. I say combine, okay? So it means that I'm gonna write it as one fraction only. So I combine it, and you see that because right over x squared is the highest degree, so I'm gonna rewrite it. I'm gonna put x squared in the front, 11x plus 24 over x plus 4. There you go. So basically, that is how you add it. You just add all the numerator together, and the denominator you keep it. But you see over here, because this is not a similar term, it's not like term, so I cannot just go ahead and combine this. Okay, and if you notice, this is a trinomial, right? And every time we have a trinomial, we try to factor them out so that we try to see that we can simplify with the denominator or not. Okay, so what do you see over here? This is trinomial. If you go ahead and factor them out, right? We already learned how to factor trinomial last time. We draw the smiley face, remember? So this is x, and in order to add, give you 11, right? So this is must be 7, and this is must be 4, right? Over x plus 4, right? Remember? Because right over here, this is remember over here this is 7x, okay, and over here this is 4x, right? This is 4x. Oh, let me erase it. Okay, this is from here to here, right? This is 4x, right? And if you add them up, give you 11x. So that is how you apply the smiley face method to factor the trinomial. And after you factor them, you see that x plus 4 and x plus 4 here the same. So just go ahead and cancel them out. So your final answer will be x plus 7. Okay. So when you have two rational expressions that are the same denominator, you just go ahead and add them up. Okay. Let me see. I can give you another one. Now go ahead and take a look at the example number 2 I have here. So in this example, you see that we have two rational expressions subtracting each other, and they have the same denominator. And this denominator and all of the numerator, they are trinomial. Okay, so how are we going to do this? First of all, because this is the same denominator, so I can go ahead and combine them together. So it will be x squared minus 3x minus 18. And I combine them. 5x squared minus 7x plus 3 minus 4x squared. You gotta put parentheses because this is subtraction of the whole thing. Okay, if you don't put parentheses, then everything will be wrong. Okay, for addition, you don't have to put parentheses, but because this is subtraction, so you have to put parentheses. So we can find x squared minus 7x plus 3. Now distribute the minus in, so we have negative 4x squared minus x plus 9 over x squared minus 3x minus 18. Okay, all right. So right now we're gonna combine line term. So if 5x squared minus 4x squared will be x squared. Negative ax plus 12 over x squared minus 3x minus 18. And if you look at this is the numerator and denominator here, they're all trinomial, so we can go ahead and factor them out. And I'm sure that this is factorable because this is x minus 6, x minus 2, right? And the bottom is x minus 6, x plus 3. And you see x minus 6 here the same, so go ahead and cancel out. So what you have left is x minus 2 over x plus 3. And that's all. This is the final answer. Okay. So most of the time you have a trinomial, usually it is always factorable. But if it is not factorable, then you just go ahead and leave it there. Excuse me. Now on the next example, number 3, I have two rational expressions like this, and if you look at the denominator, and they look kind of the same, but it's not quite the same, right? Because the order has been switched between the first term and the second term right here. So one is m squared minus 1, the other one is 1 minus m squared. So we need to have it the same. So in order to have it the same, first of all, I'm going to keep this. Okay. The second one, I'm going to keep the numerator. Then in order to switch the position between two terms here, I'm going to just go ahead and factor minus 1 out. Okay, if you go ahead and factor the minus 1 out, then you can switch between the first term and the second term. Now, negative become positive. Okay, so become positive 3m plus 2. Originally it's negative, right? But when we factor the minus out, become positive. And now you see that my two fractions here with the same denominator, so I can combine them. So you have m squared minus 6m plus 3m plus 2. And let's combine like terms, so it will be m squared minus 3m, right? Because negative 6m plus 3m plus 2 over m squared minus 1. Okay. Alright. So over here what we have, so this is a trinomial, so we can factor out again. So the m minus 1, m minus 2. Okay. At the bottom is a difference of square. This is m plus 1 times m minus 1. We already learned about the special formula, difference of square. Okay. So cancel them out. So you have m minus 2 over m plus 1. Okay. Alright, so on the example here, they has the same denominator. Okay, they all have the same denominator. Now let's take a look at this one right here. Example number 4. In this example, we have different denominator. You see, one is x minus 3, and the other one is x minus 2. Before I do this, I just want to do a quick recall. When you add two fractions with different denominator, remember, if you add 1 over 2, you add it to 4 over 5. In this case, you have to find LCD. And the LCD over here is 10, because the reason you have 10 because 2 times 5. So the same thing over here. So in order to find LCD over here, you just need to multiply the denominator together. Okay. Alright. Then we're gonna compare this LCD. Okay. We compare this LCD with this denominator, and you see that they have x minus 3, but it doesn't have x minus 2. So what you have to do is you're gonna multiply the top and the bottom by the missing part. So the missing part over here is x minus 2, because they have x minus 3, but they don't have x minus 2. So I use different color here. Okay. And the same thing here, you compare that and you see that on the second fraction, it doesn't have x minus 3. They have x minus 2, but it doesn't have x minus 3. So you multiply the top and the bottom by x minus 3. There you go. Okay. Now, everything has the same denominator already. Okay. Then we can go ahead. Okay. Then we can go ahead. So we can go ahead. Write as one denominator. Okay. Will be x minus 3, x minus 2. Let's see, I don't remember what it looks like. So over here will be 3x minus 2, and this is 2x minus 3. So 3x minus 2 plus 2x minus 3. Okay. Alright, we combine it, then we're going to distribute it. There's 2x minus 4 over x minus 3, x minus 2. Okay. Then now we're going to combine that term, which is give you 5x minus 10. Alright. Over x minus 3, x minus 2. Okay, let me check one more time again, make sure I rewrite correctly. Okay, plus it's 3x minus 2, 2x minus 3. 3x minus 2, 2x minus, oh, see that is 2x minus 3. I'm sorry. So this is give you negative 6. Okay. So so it will become negative 12. There you go. 3x minus 2 plus 2x minus 3. Yep. Alright? Alright, and now you see that 5x minus 12, you cannot go ahead and find GCF or anything, there's nothing in common. You cannot factor this. You cannot factor the top. So you're going to leave it like this. And this is final answer. And I just want to remind you this. Don't ever go ahead and distribute the bottom, okay? Because in the bottom is already in factor form. So that's good. Okay, if you go ahead and distribute them in, then why have you go backward, you know? Because it's already in factor form. Okay, factor form is the simplest form. So we're gonna leave it like this. Now let's take a look at the example number 5 here. In this example, you see that again the denominator is also different, and this is trinomial. So the best way to start is you always have to factor the trinomial. Okay, because if you don't factor trinomial, you cannot find the LCD. Okay, so this should be x minus 3, x plus 1. Okay, you should master factoring. Okay, trinomial. Okay, because you see that you're gonna see factor everywhere. Okay. Now after you factor out, then you're gonna find LCD. In order to find LCD, you're gonna take all different factor. You look at the denominator, you're gonna take all different factor. X plus 1 is repeated between these two denominators, so you're gonna just go ahead and write one time. X minus 3 is different from x plus 3, so you're gonna take everything. Okay. The step of finding LCD is so important because if you get them wrong, then everything will be wrong. Everything will be wrong. Okay. And on the test, make sure that you're gonna show me the LCD because I want to see this. Okay, I want to see this. Now after you find LCD, you're gonna compare that with the first denominator, and you see that they have x plus 1, they have x minus 3, but they don't have x plus 3. So they're missing this part. So it means that we're gonna multiply the top and the bottom by the missing part. So again, I'm going to use different color. In this case, I'm missing the x plus 3. Okay. Plus. Oh, let me use 3x. Okay. Over here, they're missing. They have x plus 3. They have x plus 1, but they don't have x minus 3. So it's missing x minus 3. It's missing x minus 3. So we're gonna multiply the top and the bottom by x minus 3. Okay. All right. All right. So right now we have the same denominator already. So we can go ahead. Combine them. Okay. We have x minus 3, x plus 1, x plus 3. Alright, so go ahead, combine them. Just combine them, okay? Don't distribute it. Don't distribute it yet. Just combine them. We're not rushing. Alright, so after you combine them, you distribute it. So 24 plus 3x squared minus 9x over x minus 3, x plus 1, x plus 3. Alright, then you combine like term. 3x squared, ax minus 9x is negative x plus 24. Okay, x minus 3, x plus 1, x plus 3. And now you see that on the top is another trinomial, and you have to see that you can factor this or not. Okay, factor of 24 is 2 and 12, 8 and 3, 8 and 3. So maybe it's factorable. We gotta try, okay? Because every time we have a trinomial we have to try. So it will be 8 and 3. So it will be 8 here, 3 here. But the bad thing is that we must have positive and positive, or negative and negative. If we have positive and positive, then we cannot get negative x. But if we have negative and negative, then we have 17, which is not good, right? We cannot have positive and negative or negative and positive. So this is not factorable. This is not factorable. Okay, so we're gonna just go ahead and leave it like that, and this will be your final answer. Okay. Okay, the square thing over here, I mean that it's just I finished them. Okay, now let's take a look at this one. In this one, you see that in the I have 4 rational expression, add them up together. And again, you're gonna do the same thing. You're gonna just go ahead, factor the bottom, but this is a u minus 1. You cannot just factor u minus 1. 1 over u minus 2u minus 1 over. Okay, for this one you can factor because u squared and you can find the g-shape. Remember, I keep saying it. You have to find g-shape. Okay. As a priority. Okay, now we're going to find LCD. Okay, so it looks like we have u and u minus 1. Alright, so we're going to take u and u minus 1. Okay, so if we compare that, well, we look like that we are the first fraction, they missing the u, right? Because the bottom they have u minus 1, but they don't have u. So it means that we're going to multiply the top and the bottom by u. Multiply by u. Okay. For the second fraction, they have u, but they don't have u minus 1. You see that? I compare between the denominator and the LCD. So you multiply the top and the bottom by u minus 1. So again, okay, in order to know what you multiply, you compare the denominator with the LCD. That's why the LCD is so important, because if you got a wrong LCD, then when you compare it wrong, and you don't know which one you should multiply, the top and the bottom. Okay, minus. Over here you have 2u minus 1. Okay, and this is u minus 1. So this one is not missing anything because they have u minus 1. This is u minus 1. Alright, now we're going to combine them. Okay, let's combine them. Combining one fraction, so this u minus 1. So 2u times u is 2u squared, plus 1 times u minus 1 is just u minus 1. Negative, you gotta distribute them negative in, so negative 2u. Negative times negative become plus 1 equal. So you have 2u squared. U minus 2u will be minus u. This is cancel out. Over u minus 1. Okay. Now, you see last time on the top we cannot do anything, but this time on the top we can find g-shape. Okay. And after you find the g-shape is the u, you cancel the u. So what you have left is 2u minus 1 over u minus 1. This is your final answer because you cannot do anything with this now. Cannot find g-shape anymore. So if you look at the first 5 problem here, you see that it's kind of very easy to find LCD. The general strategy to find LCD is you're going to take all the different factors with the highest exponent. But if you see over here, the exponent is 1. All of the exponent is 1. Okay, all the exponent over here is 1. Okay, look at that. All the exponent here is 1, 1, 1. So it's very easy. Now let's take a look at this one right here. Example number 6. In the example, you see that the exponent is not 1. It's 3 and 2. And I just say that in order to find LCD, you're going to take every factor, this is a and b, with the highest exponent. So between a cubed and a squared, you're going to take a cubed. Because higher, b squared and b cubed, you're going to take the b cubed. Okay. But between 12 and 9, how we find G-shape over here? This is, the problem of finding G-shape between two numbers. You guys already learned in middle school. So I just go ahead and do a quick review. So for 12, you can write it as 2 squared and 3, right? So you have to write it in the exponential form and prime number. You see 2 and 3 in prime number. If you write 12 equal 2 and 6, it's wrong because 6 is not prime number. So you have to write in terms of prime number. And for 9, prime number will be 3 squared. Okay. Now if you look at this one, if you look at the base here, we have only 2 and 3. Okay, only 2 and 3. So, and for 3, we gotta take the high exponent. So we gotta take the 3 squared. But for 2, we have only one option, so it will be 2 squared. Okay, then we go ahead and multiply them by 2 squared is 4, 3 squared 9. So the LCD here, the least common multiple here will be 36. Okay, will be 36. Okay, so the LCD here will be 36. Okay, so this is the problem of finding least common multiple between two numbers. Okay, there's this concept we already learned. Okay. Just do a quick review right here. Alright, so after you got an LCD, again, you're going to compare this with the denominator, and you see that they're missing this one. They're missing a b, right? Okay, because it's b squared and the b cubed, so they're missing a b. And they're missing number 3, right? Because it's 36 and this is only 12, so you have to multiply by 3. So they're missing number 3. Okay, that's for the first fraction. For the second fraction, let's see what they're missing. 9. So they're missing this b cubed, so they're missing an a, right? They're missing an a. Okay, you multiply top and bottom by a. Then they're missing number 4, right? Because 9 times 4, 36. They don't have 4. Okay. All right. So right now, we're gonna go ahead and write them. Just multiply them together. So with 3b equal, this is give you 36 a cubed b cubed plus 20a give you 36 a cubed b cubed, right? Okay. Now we have the same denominator, so we're gonna keep the denominator 36 a cubed b cubed. Okay, and we're gonna combine them together here. 28. All right. Now let's look at the top here, the numerator. You see that we cannot find we cannot find G-shape anymore because there's nothing in common between 3b and 20a. So this will be your final answer. Okay, because 3 and 20 there's no G-shape, so this will be your final answer. All right. Okay. So that is how you add and subtract in rational expression with different and the same denominator. On the third part of the video, I will be introducing how to multiply and divide in rational expression.